All right. So, yeah, when we were preparing this this panel, I was already joking that there have been probably already 1 million panels called Road to Scalability on blockchain conferences. So the question is, what can we, what is new, or what can we, where can we provide additional insights? And so the way I would like to structure this panel is basically that we have like 4 people that represent a different way how to tackle scalability, and I would like to, well, yeah, discuss from the perspective of a Dapp developer today. If you have, well, a need to build something today, there are 4 different options, and basically what are the trade-offs. So what are the timelines? When can you expect what? If you go with what direction? What do you get? And what do you maybe sacrifice if you go with this direction? And yeah, maybe shortly introducing, of course, Lefteris working on Raiden and state channels, and maybe you can give a very short summary of state channels or payment channels, Raiden.
Yeah. Can you hear me? All right. So I'm Lefteris. I work in the Raiden network. We are creating essentially Lightning for Ethereum. It's a payment channel network. There you have payment channels. That is a construct that is composed of both an on-chain and an off-chain component. On-chain, you have a deposit in the Ethereum blockchain, and then you can transact between you and your counterparty as much as you want within that deposit off-chain. That's like the summary.
Right. I mean, so in general, I actually assume that most people are familiar with the solutions, and we can go more into depth. But anyways, continue with Sunny, who, yeah, I guess represents the sidechain solutions. Or
hey guys, nice to meet you. My name's Sunny. I'm a researcher at Cosmos. And at Cosmos, when it comes to scalability, we're kind of focused on 3 main things. One is fast finality BFT. We think it can provide more scalability than most Nakamoto consensus chains. The second is application-specific blockchains. We think by segmenting applications onto different blockchains and making them specialized for their use cases, that can also help scalability. And finally is sidechains. When you have all these application-specific blockchains, you still want a single cohesive ecosystem, and so sidechains allows for you to split these applications into different chains, but still, and you get more throughput because you're having different chains doing different things, and only the users who care about a certain application have to run that chain. You're not processing transactions for other applications that you don't care about. You're only a user for the applications you care about.
yeah, I think Jordi, I don't even need to introduce because he just gave a talk. But I mean, shortly you can again.
Yeah, here I'm going to talk more about what we can say the roll-up method, or if you want the zero knowledge, using the zero knowledge of proof of computation method. Mainly the idea is we split the problem between the verification side, which is done with zero knowledge, and the data availability side. So the idea is, the main idea is that you can have maybe let's say a central operator that can take 1 million transactions, execute those transactions, and then just create a zero knowledge proof that proves that those transactions are executed in the right order, in the right way, without double spends, that are executed in the right side. And then we just prove the new state of these new transactions just on state. Of course, this has the problem that the transactions that you are executing needs to be available in order to verify, because if not, the system would not be evolved. And here is the data availability problem. Here there are, so we split the problem. And then how we solve data availability, then that's another story, but that's mainly what Ethereum 2.0 is trying to solve, or Filecoin is trying to solve, or other solutions. Maybe some federated systems can also solve. Or if you want the first version of rollup, the idea is to put this data in the same chain. So let's put this data in the same chain. It's a shorter data, but with this way, we can scale maybe 10x. And what's most important, we can test that this technology actually works, and that's the steps that we are working right now.
Right, and so Alexei might be to some surprise why he's on the panel, because he's not kind of directly working on a layer 2 or scalability solution, but we nevertheless wanted to have him because he came up, or I think he represents, well, just interesting strategies how to use the existing blockchain, the existing Ethereum 1.0 more efficient, and kind of on both sides as a Dapp developer, kind of how can you get most out of it? How can you kind of create your contracts in the most well, efficient way? And of course, also from the client perspective, how can just clients well, make optimizations to make Ethereum as it is more scalable? And maybe you can like describe a few things or
yeah. So thank you, Martin. So for the last couple of years, my main focus was to essentially try to squeeze out as much as possible out of the existing Ethereum, and now it's kind of slightly spilling out into other technologies. And luckily, recently I had more help in terms of there's 3 people sitting in his audience that are helping me now. So hopefully things are going to get a bit faster. And because the things that I was trying to do, modifying the existing implementation, they're not mainstream yet, although I believe they should and can become mainstream. And yeah, my approach is still, I'm kind of gently ignoring most of the things that are happening with the proof of stake and other things. I know that they exist, I know the general idea, but I still want to demonstrate that even without them, you can already achieve quite a lot if you are paying more attention to the implementation. And that's one of the reasons we're putting out the workshop on Friday, is to try to basically show people, at least starting to show that it's not a dark art to work on these implementation. It actually could be made a science rather than a dark art. So yeah, that's my approach.
Yeah, great. So to go forward, I would like to, well, I mean, now choosing what of those routes you go, of course, very much depends on the use case. And I would like to kind of take the simplest use case of just simple tokens and token transfers, and try to point out the different advantages or disadvantages of different solutions. So I would like probably start here, Lefteris. If you just want to have more scalable token transfers, token payments, what are roughly the factors, the scalability factors, or what are the advantages you get from state channels, and maybe what are key advantages you only maybe get with state channels or payment channels?
Well, you can get much cheaper and faster transfers, and the big advantage is the finality that you get, because we consider it final once the off-chain messages, what we call balance proofs, are exchanged. So any application that can benefit from token transfers but doesn't have any direct on-chain side effects of those transfers, because that's an important thing, would benefit a lot from using a payment channel network such as Raiden. But if it has side effects that have to be mirrored on-chain at the same time, then basically you're just missing the point of payment channels.
Right. Maybe going on.
Yeah, I would say that the application-specific side of Cosmos doesn't apply as much to token transfers, but I think what does apply is the sidechain side, which basically says that, look, you want to be able to... Sidechains are useful, or any sort of thing in which you're splitting your ecosystem into multiple things, whether it's sharding or sidechains or whatnot. Your bottleneck is always going to be the inter-shard or inter-chain communication. And so the most useful, so you want to minimize the amount of interchain communication that you have. And so for token transfers, I think, you want to try to find what emergent properties are of networks. And so, I think it's a very common situation that in financial transactions in the real world, the majority of your financial transactions are usually located like based off of geography. You do most of your financial transactions when you're going out to the store. And so, having side chains that are specific to communities, or it doesn't have to be necessarily geographic, but the idea is to look at the larger financial system and find subgraphs in the system which have a high amount of localization and transactions, and try to build side chains for those. So that way you can build a chain that really is only meant for the people in that smaller community. And then the side chains come in where when you do have financial transactions going out of that community, you can do that by side chaining to Ethereum and sending it back to the main chain or something.
Yeah, in this technology, it's probably the newest one that, at least in the STEM related. It's still a lot of things to do. The main limitation right now, for example, is the creation of these proofs. These proofs are very computational heavy things, important. Generating these proofs, some examples right now, generating maybe a 1,000 transactions or 2,000 transaction proof, it can take half an hour in a big computer in Amazon right now. So there are a lot of improvement here, trying to do FPGA or trying to do some, a graphics card and improvements in this generation. It can also be parallelized a lot. So there is a lot of work that's being doing on that. But the promise of this technology is quite high, because once you have that, you will be able to do normal transfers. You will have like Bitcoin transactions per block, and you will theoretically it scales very, very high. One interesting thing from the user is that it's very easy to do, for example, atomic transactions. Atomic transactions in this technology are quite straightforward, and probably in the first versions of the rollup implementations, all of them will have these atomic transactions, which are very important for for lots of applications, exchanges and moving tokens around.
I'm trying to kind of try to nail it down as specifically as possible. What are the unique things? So I would say with state or payment channels is probably instant finality. This is kind of something no one else can offer.
For me, what I see, what the most interesting thing about payment channel networks for payments is that you have a situation where in almost every other solution, there's a level of broadcasting data to everyone when you want to do something. While in payment channels, the nice thing is it's not like a multicast where you're broadcasting something to the entire. If the entire world doesn't need to know about something, it's a payment between me and you. We can just like keep it between me and you. We don't have to broadcast something to the entire world. And I think that's like the main. I think that's what gives payment channel networks and like things like Interledger or different payment channel networks like the scalability is the fact that you're not propagating stuff to the entire world.
Right.
Would you agree with that?
Yeah, that's a nice positive side effect, but I mean at the end you would propagate the sum up of everything that you did.
Right.
When you exit.
Probably for these fast micropayments, things that needs to go fast, payment channels probably are you cannot do it better.
Yeah, I think so.
So then, well, if those are the unique things about channels, I would say the unique thing about snarks are probably that if you trust the cryptography and kind of if everything works well there, then you don't give up any security compared to doing it directly on main chain. This is probably the most appealing thing about snarks, or
well, of course, snarks, the cryptographic primitives that you need to trust are a little bit more weak, but we have, for example, Zcash, which is related. It's using this primitive and these assumptions, and I don't know how much is what's the market cap of the snarks, but it's quite high.
For like rollup, I think it's the end goal of any sidechain thing, where it just if you currently with sidechains, you're usually trusting some sort of economic guarantees of the sidechain. At the end of the day, what would be perfect is if all sidechains communicated to each other with a snark that proves validity of all state transitions. The only, in Cosmos, we just focus not so much on that because, it's hard and, we'd rather let smart people handle that, and we just build state machines that, what's easiest to do today. But I think the end goal of all sidechain solutions is to be using snarks for validity proofs.
And then maybe touching on the point you mentioned as an advantage for state channels, that not necessarily every transaction has to be propagated through to everyone. So kind of the scalability of the data or the network working layer. So I assume that is a still probably a bottleneck. So you still probably need this operator that needs to collect all transactions.
Yeah, but can be a decentralized operator, and
Right.
at the end is, for example, the roll-up that we are designing right now is a kind of proof of stake. So if you want to be an operator, you need to put some money on the stake, and you have the commitment that you will generate that proof at specific point, or that if not, you are slashed. So that's, for example, and many of those can be competing, can be like a randomized, like very much like a proof of stake would work. But of course, there are other consensus mechanisms in order to synchronize the operators. But operators, well, I don't think it's going to, but it can be as much as we want, but it could be a very smaller network compared to the users' network.
For most roll-up solutions, would you say it's like, for which cases do you want to have decentralized operators versus just having a centralized operator?
Right now, I would be happy just to have a single network with a centralized operator. That's true, but at some point, when you want to, the problem of a centralized operator is that the operator at some point maybe can stop working. It's like the operator stop, and then what happened with the network? And then you need to define some mechanism that you can some way, or maybe other operator can take over, or you need to something that this moves on, and that's absolutely solvable. It's just a matter of designing a good protocol that sorts all this. That's an issue. It's something that we are talking a lot on that.
Yeah, so I think the advantage of staying on chain are kind of obvious, but maybe we reiterate anyway. So why not use all those layer 2 solutions? Why try to make?
Yeah, well, I think what I would say that a lot of these optimizations that you can come up with in state channels and roll-ups and other things are based on the assumption that you will do a lot of transfers, interactions, but you end up with a very small state in the end. Let's say that you had 1,000 or million interactions, but you ended up with 1,000 holders of the tokens at the end when you settle. However, if you end up with, let's say, thousands of holders at the end, you still have to settle at some point. And so one of the examples, I'm wearing this badge, which is a proof of attendance as a gentleman on the top floor is giving them up. So basically he said that he went to Sydney to the what was it called, to one of the events, and then he went to India. In Sydney, there was about 60 people to attend, and he had to distribute 60 tokens, and each token transfer would cost him like, let's say $1 in fees, and people generally can afford that. In India, let's say 500 people turn up, or 1,000 people, so the scales are quite different there, and they can't afford $1 per transaction. And so, but then in the end of this whole operation, you will need to have 1,000 people with the tokens. So whether you use the not plasma, but whether you use roll-ups or you use state channels, the end result is going to be the same. You will have the large state. So that's why I would say is that it's not correct to think that the token transfer somewhere else being settled is solving all the problems. And I would say that if we look at the ERC20, for example, in Ethereum, they generally work okay, apart from the cost problem I just mentioned. And the second problem which comes up when you start really doing things like potentially like wallets or a block explorer is that it's very hard to actually discover what are the all possible tokens out there. So I had this task recently when I wanted to find out how much of the Ethereum, let's say, state is dedicated to the ERC20 tokens. And you know, it was actually not so straightforward. In the end, I figured out it was about half of the state is dedicated to the balances of the ERC20 tokens. But in order to do this correctly, I had to comb the state many times with different combs, and it's not even, so the design of the token standard, I mean, I know that it looks very simple, but actually it has some corner cases which make this analysis harder. And I know a lot of people talked about it before. So even the simple task of enumerating all the tokens, and then when you've got a token, enumerating all the holders is also not trivial. Sometimes you actually you can have a situation where it's impossible to enumerate all the holders because of some technicalities. So yeah, that would say that it's not this scalability of transfers, but the scalability of analytics, data analytics on them, which also is a bit, it could be fixed, but I think what we could do without a level 2 solution, unfortunately, is we have to basically recognize that token has to be something native and implement it as efficient as you can. Like one of the parallel example would be, I remember when Zcash got launched and people added, and then we added the precompiles to Byzantium. And people say, well, why do we need Zcash anymore? Because we've got this precompiles, we can do everything. And I just did a calculation. I said, well, it's 300 times more efficient to do the same thing on Zcash than in a smart contract with the Byzantium precompiles. You know, 300 times, it's already through 2 orders of magnitude. It's basically far beyond the point where quantity becomes quality. It's like one of the principles of dialectics is when quantitative changes become qualitative. So you know, no, 300 times is already a huge scale.
Regarding these precompiled smart contracts, just one direct question to you is: we will see a WebAssembly in Ethereum 1.0?
1.0.
Actual Ethereum.
At this point, I don't think we will. So that's my current view of this, because I think maybe it's off topic. I don't know.
It's important for scaling also because, for example, for validating snarks in the main Ethereum, it's important that these primitives, these cryptographic primitives, are there. So one way to go is going to WebAssembly. That's the relationship. But if you consider out of topic, just please.
I can answer it very shortly. I mean, again, don't take my word for it, and maybe check with other people. But as far as I understand, the team which is working on WebAssembly, they realized that the biggest hurdle to implementing cryptographic stuff in EVM is actually the long arithmetics of the 2 to the power 250 to 56 to 500 to 212 or something like this. If you actually had some primitives for those, then most of the cryptographic things become actually quite cheap, and you don't necessarily need another execution engine for those. So maybe the better path is actually to introduce those primitives to the.
Maybe continuing with the discussion. And talk. You briefly mentioned it already. Wallets and the infrastructure that would need to exist to support those scalability solutions. So right now, if I have an ERC20 token, there are probably like 20 different wallets that I can just use out of the box, and it just works. So they just recognize the token, and I can interact with it. So as soon as my token would be like just represented in a hash in a Merkle tree or what would be in a state channel, the wallet would first just didn't recognize it. So what needs to happen for the different solutions? Kind of, is it possible to have fully general wallets for those solutions that can just support it out of the box, or will it be then very application-specific wallets, and kind of how much are the standards evolved?
Yeah.
We have a Raiden wallet, or will we have a general wallet that recognizes state channels?
Yeah, that's a very good question. Like UX is something that is going to be the biggest question for most of the layer 2 scaling solutions, because once you have the base thing working, then you have to have users trying to use it. And from what we've discovered, and also I think that you even tried, right? And then after some steps, you said, okay, no, I'm not going with it, or am I wrong?
Yeah, I tried Raiden, and unfortunately, I think I just assumed like the peers I connected to were down, and so I couldn't. That's my assumption why it didn't work. But
Yeah, so there is a ton of problems with the UX with payment channels. I know because that's what I do. I guess the other layer 2 scaling solutions may also have UX problems. So we are trying to focus more on improving onboarding and usability right now, but also do this using tools that a DApp developer or a DApp user even would be accustomed to. So we would like to be able to have a user using MetaMask and actually use a lighter form of the Raiden protocol. We are creating something called the Light Client SDK. I will also mention it in the talk for Raiden at 2:30 or 2:15 or when it is. And something else that I just want to pick up from what Alex said before is that the current layer 2 solutions, or at least us, heavily depend on layer 1 working properly and in an optimized manner. And sometimes we seem to forget that layer 1 is still far from perfect and not done. We rely so much on layer 1. Basically, we poll events, and this sometimes can be different between different clients, different optimizations also, that at some point we also get frustrated because layer 1 is not working properly. So I want to also focus that we have to help layer 1 still continue, or else layer 2 will never exist, or it will be too unstable to ever function. Sorry for switching the topic a bit.
So 2 questions I have about the UX on layer 2. One is, when it comes to wallets, for example, with Raiden, don't wallets suddenly become a lot more stateful now, where for example, on Ethereum, I have like Trust Wallet and like IM token and stuff on my phone, and sometimes I just switch between the two pretty quickly and which one I'm using for which application. But with second layer stuff, when if I have to maintain the state of my payment channels in a wallet, somehow I need a way for this state to be transmitted between my wallets, right? And so has there been any work on that kind of layer for wallet compatibility
I just want to kind of, not sure if everyone understood the thought. So right now you can just migrate to another wallet by just probably typing in 12 words with the state channel. I mean, maybe you can explain what is the state you, I mean, it's not just the 12 words, right? So
no. So essentially it's an on-chain state that you can poll by using, let's say, your Ethereum client, or with the Light Client protocol, we use other ways to poll the chain. But then, yes, you also need to have some. So for the full Raiden node, you have a full Raiden node with its own state in it. The Light Client, so we have an SDK that tries to keep it as light as possible, but this would still need to be transferred somehow. But at least we try to focus on having usage of this protocol with consumer wallets like MetaMask and IM token. So we try to make the users be in a familiar environment, so to say.
So really your main Raiden wallet will be a separate standalone software, and then there's an API that will be integrated with more consumer wallets.
So yeah, we are actually making a proof of concept one. We more want to focus on an SDK for which people can build various Raiden modules for their own wallets. We don't want to be the builders of their Raiden wallet.
Another question I have as well for the UX of second layer stuff, specifically on Ethereum, is I forgot who it was. Someone a couple months ago posted like, "Oh, look at all these scaling solutions happening on Ethereum," and I think they posted like 10, and out of those, like 6 of them were payment channel networks. And for its flaws, at least for Lightning's flaws, at least you have this one thing where everyone in Bitcoin is working on one payment channel network, and you have multiple implementations of like C Lightning, LND, and like the third one, I forgot what it's called, Eclair. You have and they're all kind of they've all done a really good job of standardizing the Bolt APIs, so that way and then now basically most Bitcoin wallets are starting to do Lightning integration now, and it works because everyone's focused on one network. How do you make sure? How do wallets choose? Oh, should I work with Raiden or should I work with Connect's channel? Should I work with the L4 counterfactual channels? How do wallets choose what layer 2 solutions to integrate?
That's a very good question. We have had a few workshops on the interoperability between the different layer 2 scaling solutions, but in Ethereum. But we also have different approaches, like some of the solutions you mentioned use more of a hub approach to payment channels, and we go for the full payment channel network thing. In the end, we would like to be interoperable with the other solutions, but that also takes work and time. First, we would like to focus on having something working and then see that we can interoperate between.
What if it's too late at that point and then we just have a huge balkanization of like wallets on we're Raiden supporting wallet, and then how do we do you not think we have to pre-plan for interoperability rather than patching it on top?
Yeah, but at some point you have to make a prioritization, because it's like as Raiden, we have a limited number of resources, and building the core thing is already taking so much of our resources that then even within the team sometimes it's difficult to not cooperate, but to synchronize.
Yeah.
I don't want to imagine how it would be with.
I mean, because I know a lot of people like to criticize the Lightning development team, but the reason it's been taking so slow is they've gone through this process of making sure they have consensus amongst all of these developers. And so I'm just curious of what are the pros and cons of these approaches?
Yeah, I mean, I think we can't solve it here now, but it's definitely an important issue, and it's true for other fields as well. So the smart contract wallets that could provide a lot of advantages, and there are 5 different ones that are not compatible with each other. So, but it's of course not easy to do it. But let's continue with a similar question to. The rollup and Snark stuff. So I recently used Tornado Cash or something like that, a mixer, and similar, my state as a wallet starts to grow because I no longer just have my my seed phrase. I, in addition, have some receipt that I made the deposit. So is this necessary as well for if you use?
Well, Tornado is just a mixer, and I would say that's just like an application, like another application. In this case, is for mixing, but it's like if you have a game or if you have a smart contract of a voting system where you will have your own state. So this is something that the wallets will have to handle at some point. For this question, before I would say that wallets, at least wallets that users use, should be user-driven. So who, at the end, who choose what should be in a wallet, what functionalities are in the wallet. If you want, but payments are the wallets will have to listen the users what they need. From the technological perspective, I think that the best we can do is just create like a reference wallet that uses the technology that you are providing, so that the wallets, the same way that when the wallet just takes many coins, and it takes Monero, and it takes Zcash, and it takes Bitcoin and Ethereum, and put them all together in order to facilitate that to the user and to make the things easier. So this is a process that the wallet designers should take in account. That's more a process on the wallet. From the technology perspective, it's like, okay, this is the Monero wallet, or this is the roll-up wallet, or and here is the reference, so that the wallets can implement inside. Right.
So I think I have 2 topics left. So one topic would be, one topic is how those solutions could work or complement each other. So which are, or like where do you see potential? Can you, for example, use channels within rollup or something like that?
Yeah, I can say they are very much independent one each other, and the work that's done in one can be used in the other mainly. For the rollup case, and this is very specific, doing transactions is quite easy because you can put just processing a transaction is inside the Snark. it's quite easy. When you want to start doing more complex things, like for example running smart contracts or running some logics with payment channels and so on, you need to embed that inside the snarks. So here, the key technology, that's like 2 steps forward, but the key technology is the recursive snarks, where you can you can validate a snark inside a snark, so you can have a big snark that's holding smaller snarks, and you can actually create any sort of smart contracts that can be validated in substates of the state that are processed with this recursive snark. So that's the technology that enables all the scaling path of the smart contracts. But that's like 2 steps forward.
Right. Then maybe the last question from my side is basically the limitations, and I think Alexei touched on it earlier. So yeah, we could go through each solution and say, what is the absolute maximum you can get, or kind of at what point, what will be the first constraint that that will limit this approach? And maybe Alexei, you can already comment where you see the limitations from the layer 1 perspective.
Well, yeah, a lot of people know that apparently the Ethereum, the size of the Ethereum state and its growth was is probably currently the biggest limitation to the scalability. And there are many ways, or maybe actually that not so many ways to deal with this problem. And we thought about 2 different approaches: is that to do the state rent and to do the sort of some kind of stateless clients paradigm. And in the beginning, it seemed like the stateless client weren't really feasible, and so the state rent was the solution. But now I think it's kind of not certain this way. And so the limitations that start to come up in terms of the stateless clients, which I'm currently mostly researching, is that it's essentially some design decisions which were made when Ethereum was created, unfortunately made it more costly for the rolling out of these things. For example, if the try in the Ethereum state was binary instead of hexary, the proofs that would be required in stateless clients would be much smaller, like maybe 3 to 4 times smaller. And so also complexity could have been done, could have been improved. So we're actually even thinking about maybe we should replace the hexary tree with a binary tree. I mean, it also sounded like a preposterous idea to me like 4 months ago or something. But now actually I don't think it's so preposterous anymore. Maybe that's still possible. And so the limitations could be removed. I don't know how many of them there are. And I don't even know, I haven't finished prototyping how efficient can we be with this. For example, if you take the stateless client approach, this is where if you take it to the extreme, then you would start seeing the lines blurred between what people call level 1 and level 2. Because essentially you would have segmented the network into the nodes which have a very small part of the state and they can still operate, they can verify everything, and the nodes which have most of the state or all of the state, and the ones are helping the other to operate. And this is, and if this is supported natively on the protocol level, then people don't have to think about all this, lots of these solutions which are keeping the data off chain and putting the Merkle root on chain. They wouldn't even need to be done because that would be automatically supported. You just put some stuff in the contract as you used to do before, and the protocol is going to take care of that. The whole thing is going to be just transported as block proofs. And this is where I see that the effort which we could do on the core level will actually just reduce the effort that every dApp developer needs to do on on their own version of layer 2. And this is where I could see the lines started to get blurred. But that's why I think I'm not sure about limitations yet.
In the roll-up idea, I would say mainly 2 limitations. One is the generation of the proof. As I explained before, it's a heavily computational power that you need to generate that proofs. But the good news is that this parallels very, very, very well. So with, maybe with not this curves, but some other more bigger curves, we can scale very much because the operators can be, big data centers with big clusters and can be really great, a lot of transactions in that side. The other that I would say probably is the most important limitation we have right now is the data availability. We need data availability there. Of course, if you put the data on chain, the limitation is how much data we can put on chain, which is not much. And if we put well, there are some crazy ideas of using other blockchains like Bitcoin Cash and other stories. But Ethereum 2.0, for example, the first stage is going to be mainly a data availability network. So, and this, this can scale. You can have thousands of transactions per second easily just in Ethereum. Then there is other technologies like Filecoin or other chains that are very specific for data availability thinking. And there is also other solutions about data availability. You can also have a federation of service, which are not so nice. But from the pragmatic perspective, if you just ensure that the data is available because you have 10 servers running with some trusted parties in different places on the world, then data availability is not a problem anymore. So you can scale very much on that if you assume that. Data availability, it's a little different, because this is important. It's different of a consensus. In consensus, you need like 2/3. Data availability, you just need one server that guarantees the data is available, which is it's a weaker requirement on that.
And kind of limitations in terms of number of constraints or something like that?
There is, in the current curve, there is a constraint, in the current curve that, for example, that you can validate in Ethereum, there is a constraint that maybe you, depending on the constraints of the transactions, but it can be around 2,000, 1,000, 2,000, 3,000 transactions. It's a limitation, math limitation of that curve. But if you just choose other curves that are bigger with, bigger fields and so on, you can grow there. So it's just a math. It's just a math limitation there. I would not even consider a limitation in global, in the long run.
So limitations of, I guess there's for Cosmos. On the Tendermint side, there's like you do have this n² problem where as you increase the number of validators, your consensus becomes much, much slower. And there's a lot of work being done by our team as well as many teams throughout the space on how to improve that even further. From the Cosmos side, I think the main limitations are that the obvious one is as you go onto more and more side chains, the security of any individual side chain does decrease. But I think, personally, I think that's okay because, you should be using as much security as you need for an application, and not all applications need to have the optimal security. And I don't even think that all applications need to necessarily settle to the chain with the maximum security. And then I think, and so with the drawback, you do trust the counterparty validator set to be doing proper state transitions. And if they're not, the way we design Cosmos is we try to make our interchain relationships such that corruption on one chain does not affect the global ecosystem. And so the simplest way to do that is we focus on token transfers for now. And there's a way to do that using other systems as well, like Agoric and whatnot. But with things like rollup and stuff and snarks, we can eventually make it so we don't have to rely on those validity of state transitions anymore. Then we're really only relying on the counterparty validator set for things like censorship resistance and double spend resistance and stuff.
No, writing is awesome. There is no problems.
No limitations, no limit.
Nah, I'm kidding. So one big one would be the layer 1 actually working properly and being optimized, because we have had so many problems between the two major clients that we are using, so Parity and Gith,
It's mainly around events or something else?
Events and return and error codes and the way that they handle pruned state, when is the state pruned, how do they handle the technicalities? It's all technicalities, but hey, when you're developing software, that's all that matters. So that is one. And another major one in payments and networks is proper network health, because you have payment channels and they all form a network together, right? And each channel has a certain capacity of tokens in it. And so after a lot of transfers, a channel can be depleted towards one side, so to be completely imbalanced, and then the paths get all messed up, and you can no longer send payments properly through the network. We are working on that. We are introducing, I will talk about it also in the 215 talk, a pathfinding service that tries to provide optimal paths through the network that also take into account the balancing of the network. So the fees, using the proper fee model, we are trying to incentivize having a healthy network.
All right, well, so to close the panel, I would give everyone again the opportunity to kind of do a call for action or something like that. So is there something where you say, okay, what are steps that maybe developers can try out now or implement now or use now, or where is the state?
For us, so focusing again on payment channels, a call to action would be to try to use our software and provide us with feedback. So after Red Eyes, after the December mainnet release that we have gotten so much feedback that really helped us and helped pinpoint a course forward for us. So the more of that we get, like also the feedback that you gave us was pretty good. You will see we have a Raiden wizard now that will make everything that you were imagining about Raiden just work in 5 minutes.
Yeah, so on that one, I think I can also advertise Dep node. So Dep node makes it actually very easy to set up a Raiden node. So yeah, definitely encourage everyone to try it out. And I think there will also be a talk or presentation about Dep node. Anyway.
So we just published our IBC spec like 2 weeks ago, and so I'd love for people to take a look at it and see how to start implementing it in different frameworks, because it's essentially a very well-abstracted sidechains protocol that can work across a number. It's pretty generalized, and it can work with different consensus protocols, different state machines, and whatnot. And so we're implementing it right now to have Tendermint chains talk to other Tendermint chains, but it'll be great to have more, and using the Cosmos SDK, it'll be great to have people implement it into like a Go Ethereum fork, or as a smart contract, or on Substrate. And so we'd love to see more usage of IBC as a standard for how to do sidechain protocols.
On Ethereum, there's obviously this proof of authority sidechains that would work as well with the standard, or would
right? So that yeah, it'll be great to see like people using So I'd love to see the proof of authority sidechains, for example, maybe using the common sidechain protocol. I think like I think one common theme that we've seen throughout this entire talk was that there's a need for more standardization and so that's what really I think we should be pushing towards.
Any call to actions?
Here is mainly right now the battle is very much in scaling this computational side. It's something that's very technical, but anybody that knows about programming GPUs, that knows about programming FPGAs, it's very welcome, because there is a lot of things to be done in that side. Of course, also there is, we mentioned a little bit all this coordination of the operator, when we want to decentralize the operator, how we can coordinate the operators so that there is a collaborative way to do it, so that all of them compute the proof, not only the one that's assigned of that. There is a lot of work to do in that side. Of course, wallet, client sides, there is also, because this needs to be done, testing, documentation, learning snarks. It's a full world, so everybody's welcome to jump in here, and it's an exciting world.
Yeah, so I would say that we identified the shortage of essentially core development in Ethereum. Well, people talked about it for some time, and so I don't know exactly how we're going to do it, but I think we need more forks of the general purpose clients, and we need more experimentation about like how could you do this and that differently, maybe more like a purpose-built clients, not just the one that is kind of can do everything but in an average way, but can do some things really well. So again, there's a lot of obstacles to that. There's motivation, there's funding and things like that. I cannot solve all these things, but at least I say that's the direction. And of course, we have this workshop on Friday, but obviously in 2.5 hours, we can't really teach everybody from start to the end. We really squeezed in time. So hopefully that will be inspiration and for us and for all other people who can join. We might do more of those things and just start showing that this is what people can do, and yeah, just learn how to do it themselves.
Yeah, Alexei gave me already a preview, so on Friday the workshop will be about, well, just picking a very simple EIP and trying to implement it and actually getting it into, making the proper code changes. Yeah, well, thanks everyone so much. I think, well, time is over, but we could allow 1 or 2 questions if there are. Otherwise, well, next there's the lunch break. But if there are 1 or 2 questions, okay, we covered everything. Thanks, everyone.